Hi, good morning, and welcome to the ZP webinar. So we like to do this webinar every Thursday at about 8 a.m. London time. I've gone a little bit early, and I also apologise if there's any background noise as well. I do have a 3D printer in this office, and it may be a little bit interfering, but I apologise for that. It's a big job, and I have to print it. That said, I'll go forward and just say we do our weekly webinar. Today's the 1st of February 2024. And just checking that, yep, that's correct. And a lot of what I'll talk about today will actually feature the food sense generation 4, and not the food sense generation 4, sorry, the Sense It All platform. So there will be a bit of coverage on this piece of hardware today, but hopefully I'll also be talking about some other aspects as well. Just to say, it's super relevant if people can come to our Sense It All webinar. It's free. It's on the 27th of February. But a lot of what I will say today is relevant, let's say, there. So please do come to that webinar. If you see a link pop up, by the way, that link, I'll make sure I put that link underneath the video as well. That said, so one of the ways of finding out sort of information from Zimmer and Peacock is actually our corporate and consulting workshop. So I hope that people are aware that we will come on site and do these types of workshops, and so that some of the information is unknown, or you like to get your team trained up. Please know that we do these workshops as well. We also do workshops at our site as well. So on the 2nd of March. There's a 2-day workshop really about what we call CGM, continuous glucose monitoring, also continuous lactate monitoring. That's something that's appearing in today's webinar. And also we do IVDs, in vitro diagnostics. So a lot of what will be discussed today will be in vitro diagnostics as well. All that said, any links that pop up, then I will make sure that we put those links underneath the video as well. So I will go forward a little bit more and just say, I'll just skip this for now. The questions that we are covering today are that so there is a technology out there called the ecflex. The ecflex is an old piece of technology from us, and I'm not entirely sure. Well, no, I am sure that it's not something that we're going forward with. So I will discuss ecflex. Somebody's interested in exercise and sensors for exercise, so I will touch on that very quickly. Somebody else is very interested in these electrodes, these MS gold, I want to say gold third time 101s. So I will touch upon that as well. And also somebody else is very interested in alcohol sensors, so I will touch upon alcohol sensors as well. And then I've hidden it slightly here, but somebody's very has a certain particular potentiostat. For their anonymity, I'm not going to mention the potentiostat, but I will talk about how to check its calibration at the end of this webinar. So ecflex. So the ecflex, we've had the ecflex now for over 5 years, easily over 5 years. It does say it on the website, but it does actually say it here. The ecflex has now been replaced by the single-purpose biosensor circuit, which we have linked to in the adjacent button. So I suppose it's just a way of saying people can ask questions on it, but it's not a technology that we've actually gone forward with. I think we've mostly taken away the buy now buttons, or we put it as sold out around the various websites. So obviously if we haven't, people can help me correct that. But as it is, I think we've left the information up just for sort of historical, because people are sort of curious about it. But as a product, it's not there, and it's replaced by the single-purpose biosensor circuits. It's a very old chipset, and we did have to modernize it. It is replaced by this guy. In a minute, you'll see links to this jump up. So in fact, there we are. So there is a replacement, and it's not very well named, but we do call it the single-purpose biosensor circuit. This is the circuit, and everything else around it is really what sort of a developer's kit, a breakout board, let's say. So You can use it with our sensors. I mean, this is just for scale, just to sort of see how, you know, so it's not an Arduino, let's say, but, you know, it's kind of that sort of idea that, you know, there's a single purpose biosensor circuit. This is the breakout circuit, so you can kind of communicate with it, and this is the one of our sensors, you know, put into that board. So it's quite well supported. So that's what is replacing, or has replaced rather, the ecflex. So the questions about whether we can 3D print to it and stuff like that, it's not a product that we're supporting going forward. We acknowledge that we had it. It's a very old chipset. There are better chipsets these days. We've come a long way, you know, ourselves in the decade that we've now been around, and we have, you know, finally replaced the ecflex. Again, any links, I'll put the links underneath the video. As you've identified, that can be used with a number of our sensors. ZP does have a large portfolio of sensors. We do hope people still get the sensors and still get the single purpose biosensor circuit, but the ecflex is not something that we're supporting going forward. For this person, I would definitely please do come to the webinar on the 27th of February. We do 2 sessions, one in the morning, one in the afternoon. The one in the morning is meant to help people in sort of Asia and in Europe attend, and then the one in the afternoon, our afternoon that is intended for people in the USA, Canada, the South Americas. Don't worry about it saying January. This link will take you to something that's happening in February, so I hope that's useful to you. It's probably worth saying that at ZP, in fact, I've got a couple of examples here. At ZP, we are very active actually in wearables. This is a smartwatch. It's a smartwatch using microneedles. It's probably worth saying, I mean, here's a sort of sports version of it. It's probably worth saying that these wearable technologies are protected by something like 50 patents, so it's quite a nice technology. And of course, if people are going to adopt this technology, they have to understand that, you know, their investors will say, well, it's all very nice that you're adopting that technology, but do I have a freedom to operate? And the thing about this is that it has 50 patents behind it, so it really gives, if you want to adopt this technology and you're well funded enough to be able to do it, this is the watch itself. We can use this with glucose, lactate, ketones, the kind of analytes that people are interested in. It's protected by 50 patents, so it's really important because people do want to license in and use this kind of technology. But the first thing that their their investors are going to ask is, do I have a freedom to operate? And the fact that there are something like 50 patents behind this really helps in that question, or answering that question. This question really is about lactate sensors. So let me sort of slightly jump into this. Somebody wants to measure lactate. They're a high school student, so we do have this kind of technology, but I wanted to say it's not available commercially. We do this kind of technology really on projects, but we do have the ability to put our sensors into these kind of sweat patches. We can adhere these sweat patches to humans. This is in our offices in Norway, and we are able to communicate the technology via Bluetooth. So I do recognize your question. We don't have something that you can just commercially buy and get off the shelf. This is the kind of work that it is. It takes a lot of engineers. It's really kind of, you know, senior guys have to get involved in this, and it's not, and girls of course. So it's not something that we can make commercially available, but I just want to say that what you want to do is possible, is technology possible. And here's a case study of ZP that we do it, but we really do it with clients on client projects, and it's not something that we just have kind of commercially available. Question number 3 really is around a particular electrode that we have on the website. So this is the electrode. It happens to be gold. The one they're interested in, I know I've shown this one with a silver chloride reference. I think they're interested in the gold one, but it was the image that I had quickly. But it doesn't make any difference to the conversation. I think I want to back up. Yeah, so they're asking about this particular electrode. I've linked to it here. The questions they have is they want to fabricate a customized electrode, but I think that their desire for customization is driven by the fact that they want to have a combined counter and reference electrode. So I don't think that you need to go to customization in order to do that. And in fact, I would encourage you not to go to customization. Customization is expensive. It leads to unless you can get to high volume, and so they're asking for something like 50 to 100 electrodes. It's not high volume. See, high volume is hundreds of thousands of pieces. When you get to high volume, then you can start having good repeatability and good quality. So a lot of companies will give you customization, and they'll even give you customization at low cost. But what you find out then is this terrible repeatability in your tests, and it's due to a poor reproducibility in the electrodes themselves. So I think you can get to what you want to do on standard parts. This is a slightly different question, because the first part of the question is about, they're referring to a PCB system, printed circuit board system, and then the second half of this question is about screen printed electrodes. Our screen printed electrodes are copper free. I mean, we all know that copper would obviously would oxidize in a lot of electrochemical experiments, so I understand why you'd ask it. With regard to screen printed electrodes, it's a bit unusual, but all right, there you go. Talking about the customization part, so for example, that electrode that you're interested in, we have connectors for it. The particular electrode that you refer to is 10 millimeters in diameter. I have to emphasize the 10 millimeters in diameter, in width rather. I have to emphasize that because we do have connectors, but you are looking for a connector that would be the 10 millimeter slot, not the 7 millimeter slot. 7 millimeter is relevant in a short while because somebody else is asking a slightly different question. But you're asking, the material you're referring to is 10 millimeters. Now the reason I bring this up is because you want to combine the counter and reference. So with this connector, you can stick your banana plug in here and that'll connect to the working. You can stick your banana plug in here, that'll connect to the reference, and you can stick your banana plug in here and you can refer to the counter, or rather you connect to the counter. So that said, most banana plugs, I haven't seen your potential stat, I don't know what potential stat you have, but most potential stats these days have these kind of connectors on them, and that means that you could actually short together your counter and reference coming off your potential stat or coming off your instrument. So even if you've got 3 wires, let's say, one for working, one for counter, one for reference, you can shorten on your potential stat by just plugging the counter and reference together, and then you can plug that shortened, those two cables that we shorted together into one basically female connector here. So you don't need to do a custom piece in order to reduce a section. Essentially, I think the question is, can I reduce a 3 electrode system down to a 2 electrode system? You can do it just off this connector. So I think you're better off to do that strategy, because then you're piggybacking off the back of materials that we're making in high volume. So that means that you'll get reproducibility because we're doing it high volume, and therefore your experiments will be repeatable. Otherwise, a 50 to 100 pieces is such a low volume, you won't get reproducibility in manufacturing. You will get people who will do this for you, but it just won't be a very good quality. And if you so wish, you didn't have to short these two things and stick them into this side. You could actually have done it on this side as well. So I'm just saying to you, you can achieve your, essentially what I think you're trying to do is reduce 3 electrode system into a 2 electrode system. You can reduce it just using the cabling and just using the connector, and then you can avoid the whole, I need a customization part, because it'll just end up being possibly expensive and possibly poor quality. It's probably worth saying that at ZP we do have a whole bunch of screen printed electrodes, including a gold one, which I think may be what you're interested in. These guys are all, these ones are all 7 millimeters. So you've got to be careful that earlier on you were referring to an electrode system that was 10 millimeters wide. Now I'm recommending some screen printed electrodes that are 7 millimeters wide. It's just because when you look at the connectors, just make sure you get the right connector for the electrodes that you choose. Any links that I'm showing now will also pop up in the underneath the video once I've done it. The reason I'm kind of slightly saying don't go for customization too early, try and think around this customization request, is if you watch any of our webinars, please come to the webinar on the 27th of February. You will find links underneath this video when I've finished. Please come to the webinar on the 27th of February, because you'll see that when we do our work and our demonstrations, we never do any calibration. The problem that you see a lot in a lot of academic papers, they either normalize the signal or they either do a calibration or they normalize the signal. And the reason being is that actually they have an irreproducibility underneath the electrodes, on their electrodes, and that's what I'm trying to avoid for you. So come to our webinar, because then you'll see this is a true case. Because when we're manufacturing something, not talking about the kind of request for customization, but when we're manufacturing something, we really make sure that we really kind of map all out. Well, we make sure we test all the pieces, but it takes a long time to set up manufacturing and get manufacturing reproducible. So when we sort of advertise our screen printed electrodes, I just showed 5 of them earlier on, there's a real quality system behind them that we're checking the batch by voltammetry, making sure that we've got repeatability. And this is really relevant to the lady asking about the potential stat later on as well, but we're really checking these screen printed electrodes, making sure that the quality. And so that when you get them, we know that, what is our relative standard deviation, that our relative standard deviation is within acceptable tolerances. There's a bit of a rule in life that we really want the RSD, the relative standard deviation, to be better than, or to be less than 20%. That's on a final assay. But actually on the screen printed electrodes, we want it to be lower than that. So we're making sure that we're below sort of 10%. So in this case, we're at 6 and 5%. That is possible because we've put so much effort in over the years on screen printed electrodes and setting up the quality systems and the manufacturing. So if you go for customization, all of that is not in place, and you will find companies that will definitely do this for you, and ZP would do it for you, but I just don't want people to do it because I just don't think you're going to get the manufacturing reproducibility, therefore you won't get the repeatability of experimentation. So effectively, you're discarding data sets because the underlying electrodes are not reproducible. And I think you can actually achieve what you want to achieve by just using the right connectors and just by shorting some cables together. So this is just to kind of say that when we're doing work on our electrodes, we get really good signal, and these are all, at each concentration, we actually did it on triplicate on 3 different electrodes, and you can see that we get really good repeatability, which is really reflecting the reproducibility of manufacturing underneath those experiments. So be careful of customization is my kind of comment. Especially 50 to 100 pieces. It's not manufacturing. It's just something very, very low run. It's in fact almost hard to make 50 to 100. So I recommend just using something off the shelf and trying to use a bit of cunningness to go from a 3 electrode system to a 2 electrode system. I've given you some ideas there. Somebody else is interested in our alcohol sensor. So at ZP we have a whole platform called Sense It All. Come to the webinar on the 27th of February because if somebody wants to use an alcohol sensor in a new application, we can do it really quickly off our platform. So at ZP, we do have a whole bunch of biosensors. This is not all of them. The website has histamine on it as well. But we do have it, and alcohol is one of the sensors that's on the website. And we do have, and if you see a link, by the way, that link, you'll follow that link. We do have the data on there. But what I want to say is, for every application, questions like sensitivity, interference, limit of detection, those are application specific. So even if we have a sensor on our website, that doesn't mean that any metrics that we have are translatable into your application. So if this person's looking at beverage or food, that's a very different application, and that would take a really specific conversation whether our alcohol sensor and how well our alcohol sensor would work in there. So be careful, because our the thing that's different about biosensors versus other sensors is that the sensor is in really intimate contact with the sample. So if you had a temperature sensor, it doesn't matter what you stick the temperature sensor into. Often the temperature sensing element is behind, some walls or some insulator, and so the temperature sensor is not sensitive to the matrix that you're necessarily measuring in. But when it comes to biosensors, you're right in the sample, and the sample becomes part of the signal. So it is hard when people say, well, what's your limit of detection? It's like, well, what's your application? But we do have the data up on the website. But I do want to say that at ZP, we do have, in fact, I've got one here. This is the this is the Sensi Ore platform. This is our capability of actually getting people to market really quickly with our biosensors. It's what we call an OEM platform, an original equipment manufacturing platform. So if we talk about the alcohol sensor, you take the alcohol sensor. For every sensor we have a QR code, and the sensor works with an app. If you're watching this live now or you're watching a recording, get ready with either your Android phone or your Apple phone, because you'll be able to scan a QR code in a bit. There's a Julie database, so we have a whole system for sending data to the cloud. You put the sensor, in this case the alcohol sensor, into the meter. You put the sample onto the meter. The meter is driven by the app. The app gives the data to Julie, and you get a concentration. Now it's alcohol, so you might want this in percentage, because that's what that kind of industry likes to have. But what's really cool about this system is that it actually sends all of the data to the cloud. Now, we can't, at ZP, we can't see your data unless you share it with us, but it does really help us support you, but it also helps you support your own customers, because actually you get all the data in the cloud. So Sense It All as an OEM solution for people who want to develop applications for alcohol is really good, because it's very cloud enabled, and it's actually a really nice piece of hardware as well. I mean, come to the webinar on the 27th of February, but it's got these kind of LEDs on the front, on off button. If people happen to spill things, we can take it apart quite easily, you know, and it can all be cleaned up. So it's really quite elegant. So please come to the webinar on the 27th of February to see that. But in answer to your question, the limit of detection is really application specific, and without knowing the application, I can't really get to the answer of that. It's probably worth saying that this piece of hardware, when I say this piece of hardware, this OEM solution that I'm holding in my hand at the moment, next to my head so you can get a sense of scale, is pretty small, very powerful. It works with our biosensors. What's nice about it is no more slots. You won't really be able to pick up on this, but actually the way this works is sensors, we click the sensors in. There's no more trying to put an awkward sensor into an awkward slot. So it's got some nice features, no more slots, so that's really nice for your end users. Elegant little cartridges that self-align. It's very cleanable. By cleanable, I just mean you can actually take it apart. Somebody spilt something, I don't know, some dairy product on it. You can take it apart. It has these user lights on the front to sort of really guide the user experience, different colors for different states of the machine. It's either compatible with Apple and Android. It's cloud enabled, so every test actually gets saved in the cloud. So this, and it also, we have what's called an API, an application program interface. So you can pull that API into laboratory information management systems, or rather you can bring it into laboratory information management systems. There's also order fulfillment. So we can, if you're a startup and you really have you have no operations, that's people who can do shipping, etc. We can drop ship that around the world. It's priced very aggressively. So if people are able to get into, let's say, 10,000 per year, then we can do this at 60 euros each. So that's pretty aggressively priced, and it's compatible with microfluidic cartridges. As I say, if you've got a smartphone now and your Androids, scan this code, because the only thing I would say is that the software is not super useful to you unless you've actually got the hardware, but just to say that we have already distributed the software, and it's also on the App Store as well, so that will work off a smart phone. So for every let's say sensor or assay that we run, we have different codes. This is for doing chili assays. This is for doing ginger assays. This is for doing nitrate assays. This is for doing total antioxidative status assays. TAS is something that they do use in the food industry for predicting shelf life. It tells you about the number of antioxidants in a product, and we spend quite a lot of time and money making that TAS sensor. Last question now is about potentiostat. So somebody's asked us, I've got a particular potentiostat. I have seen this potentiostat, and I have made some videos on this potentiostat in the past, but I haven't touched this potentiostat in years. It's not something that we sell or we distribute, but I'm aware of your potentiostat. Well, by the way, it's not this potentiostat. The only reason I bring this potentiostat up is actually I do happen to have one of these potentiostats here, but it's just something that I want to talk about quickly now. So this is a typical potentiostat. The one that they have actually is slightly smaller than this. So to be fair, well, it is smaller than this, to be fair to them. But it's not as small as this. And the reason I bring this up is because we do a potentiostat in this form factor. We call it Kate. because I'm really passionate. So I hope that people will come to our webinar on the 27th of February, because I'm really passionate about actually getting products to market. So the problem with potential stats like this is a good potential stat, by the way. I mean, I own it, as you can see. But it's not something that I any longer use in development, because I want people to develop on products that look like something that they could actually take to market. So good potential stat, does run well, works well in these kind of, you know, beaker type experiments. But I want people to really do experiments that will bring electroanalytical assays to market. So I'm very keen on using instruments like this. So we do have an instrument that looks like this. It's called Kate. I am going to help this person in a minute to understand whether their instrument is working correctly. So to understand whether your instrument is working correctly, I would suggest getting one of these 501 screen printed electrodes, which I'll link to here. Getting one of these connectors, but you need one of the connectors with a 7mm slot. I'm not entirely certain on your potential stat what your banana plug diameters are. My guess is your banana plug diameters are either 2mm or 4mm. But I bring it up because at the back of this connector there's holes for your banana plugs, and you either have to choose the 2mm or the 4mm one. But you must be careful to get the 7mm slot at the front here, because this 501 is 7mm wide. You need a 7mm slot. And then we do solutions, but really you just need to make yourself a 5mm ferricyanide solution in something like 1 molar KCl, and that will be good enough. But if you have problems making the solutions, you don't have problems making the solutions. I've seen your background. I understand you're a doctor of chemistry, so I understand that you'll be fine with it. But the reason I bring that up is because we use these kind of solutions, and then we do the voltammetry. Once you've got the 501, this is voltammetry off the 501. I can look at your voltammetry, I can look at our voltammetry and make sure that your instrument is essentially behaving itself, but that's how I would do it. I just want to say that, as I say, I mean, I do own these potential stats. I don't longer use them because actually I want our guys to be using these types of, and this is actually a potential stat as well, we call it Kate, because it looks like a kind of, you know, it gives our guys the mindset that what they're doing in the lab can actually translate into products. So I'm just going to put some links to that here. So please, and also I would say to you as well, please come to the webinar on the 27th of February. It does talk about the whole philosophy at ZP, you know, that is really about getting people's experiments from the lab and actually onto the market. And things like the Kate potential stat, the Sensi are all examples of that. So question number 1, ecflex, good instrument, very old chipset. We have discontinued it. It's replaced by the single purpose biosensor circuit. Question number 2, I want to say that what you're wanting to do is achievable, and because you're a high school student, I want to be, you know, encouraging. It's just to say that, you know, these are, you know, for us, these are quite large programs, and, you know, we do use the top engineers that we have on those kind of programs. So what you're trying to do is actually not commercially available today. With regards to this particular electrode, it's a 10mm electrode. I think you can achieve your shorting of the counter and reference together just by using connectors and cables. And yes, our screen printed electrodes are copper free. There is a gold hypervalue electrode that I think you should try. Question number 4, what's the limit of detection of our alcohol sensor? It's really application specific, but in fact, if you tell us about your application, we've got an entire technology stack that could get you to market really quickly. Question number 5, if you get that 501 potential stat and those connectors and you test it with a 5 millimolar ferricyanide solution, I could tell you whether that potential stat is working correctly or not, no problems. But it's not a potential stat that we sell, support. I have touched it, I have made some videos on it in the past, but those videos are pretty old at this point. But we can help you, but only if you're able to sort of standardize your testing so that you test the same way that we test, and then we can compare, let's say, data. So I want to say thank you very much. I'm sorry I spoke very fast, and I'm also very sorry about any background noise today, and I'm also sorry about any bandwidth issues that I might have otherwise been having. But thank you for the questions. You can see that we do put a lot of effort into answering questions, and we try to illustrate them as well. So if you've got any questions, please don't hesitate to reach out to us. Okay, thanks very much.